Our project is on the molecular engineering of food grade dispersants. We have a very simple and important concept. So currently, when people look to treat an oil spill, they use a class of molecules called dispersants. What these dispersants do is that they break the oil slick into a series of droplets which are carried below the surface of the water, where they are degraded by bacteria. Now, the current dispersants use some synthetic molecules. Essentially, some of those molecules are not something that you would want to ingest. That is, they may be arguably somewhat safe, considered safe, but again, they are not food grade. Okay? What we intend to do is to make a new dispersant completely out of food grade materials. So it's indeed something that you potentially could even eat. Okay? And we are building on a series of results from previous work funded by GoMRI, where we have found that a combination of food grade molecules can actually serve as a pretty good dispersant, almost as good as what currently is being used. And so this project is our attempt to carry this further to refine and optimize our food grade material for its ability to disperse oil spills at the smallest concentration possible. And also, to the key point about having something food grade is we hope that it's non-toxic. So we want to also demonstrate this non-toxicity not just to humans, but most importantly to aquatic life as well as to microorganisms. So we hope that we can offer a viable, safe alternative to existing dispersants, and that this could actually be used for a future oil spill. Essentially, it's a team of chemical engineers, and what we do is engineering at the molecular scale, and the molecular scale then overlaps with the nanoscale. So what this means is that when you take a slick of oil, a film, and you want to break it up into small droplets, these droplets tend to be in the microscale or nanoscale, and our molecules will end up coating these droplets and thereby preventing them from aggregating and forming a slick again. And so it's about engineering the molecules, not necessarily from the chemistry side, but from the choice of molecules. We have several goals. From the applied standpoint, we want to actually come up with a viable material that could be used for future oil spills. From a scientific standpoint, we want to learn the process of dispersion. That is, again, as I mentioned, we're starting out with a thin film of oil on the top of the ocean, and this is going to be broken down into small droplets. How does that process actually occur? We want to understand that from a scientific standpoint. I mentioned also that the droplet should not re-agglomerate and form a slick. How do we ensure that that doesn't happen? So there are important scientific principles that we hope to learn from our project.